In previous episodes, we installed an electric motor in the car, connected it to the axle, and mounted retractable steps. In this episode, we'll finish all the metal work around the car so that we can finally start working on the exterior soon. First, we tackled the sliding side door. Of course, it will be powered by an electric drive, and later on we'll synchronize it with the retractable steps. How will this work? After pressing a button or receiving a signal from a sensor, the door starts to open, and at the same time the step extends. In our case, there are two steps. Basically all this time Kolya has been working on the door frame, simultaneously solving a puzzle and assembling a bunch of parts from different cars into a single mechanism. Of course, there are no ready-made solutions with rails and guides, but we do have ingenuity, a welding machine and an auto salvage yard just down the street. And after just 2 days, this kind of structure is starting to take shape. Essentially, it's a simple reinforced square. Since the body will be transparent all around, we decided not to add any diagonal reinforcements. And finally, the first fitting. Quite successful for first fitting.
The frame of the side door has been assembled. For the frame itself, we use the 30x30 profile pipe so that when we eventually glaze the exterior, there wouldn't be any intermediate elements here. There were none at all. Rails, we placed one at the top using a side rail from a Gazelle here. At the bottom, we use the side guide from a Media, from ISZ Media. And here we also use the top one from a Gazelle.
Hey, did you have any other cars? Only Gazelles and Medias, that's it? No, we didn't. MTS and Sprinter are a good option.
Too expensive.
Expensive and fancy?
Expensive and fancy. But the only big advantage Gazelle has, compared to Mercedes, Yuzu, and all the others, is that all their guides to top, middle, and bottom are all removable from the body. They're separate parts. That's why we specifically use the ones from the Gazelle. And they're available. You can easily buy new ones. They're easy to maintain. And everything you need for them is out there. As a result, our door opens perfect.
And what about the drive? Will it be electric or mechanical? It'll be electric, using an electric motor with a remote control. There will also be catches installed here to hold the door. When it closes, it will always close with the same gaps. And here, a lock will be installed at the top, along with an electric actuator. Listen, all of this is nonsense. Physics won't let you do it your way, because pushing the door, just look at every minibus. The drive is positioned in the middle of the door, but in your case, the drive will only be at the top. So if your drive only pushes the top part of the door, the bottom part will move diagonally in the opposite direction. And what does that lead to? That your door will get stuck? Guys, this is all nonsense. That's what it comes down to. You're making me grab my tools again. The latest nanotechnological developments of my own hands? Where are my gloves? All right then. There we go.
In the end, Valeria had to do some very fine tuning, after which we could move on.
Another batch of spare parts has arrived for us. This time as for the electric door drive system, we decided not to completely reinvent the wheel and just went with a readily available, well-established solution that's often used in various minibuses and larger intercity buses. Let's unpack it and see precisely what we've got here. What has arrived, this is essentially a robust gear rack, along which the motor will smoothly move. Here we have some electrical Waringa veritable spaghetti, as they often say. And this particular component apparently is the drive unit itself. Yes, it doesn't look particularly impressive or visually striking, but most likely that's just the external casing. We'll modify it. The primary and most important thing for us is that the entire mechanism functions correctly. The comprehensive kit also includes a protective curtain, additional electrical wiring, and a sophisticated control unit. Along with all that, there's also a key fob and various small hardware buttons, bolts, nuts, and screws. We're going to try installing it now, see how it fits, and test it out. But most likely nothing will fit, and we'll have to redo everything anymore.
In fact, it turned out just as Kolya expected. But to get ahead of myself, I'll say we only had to redo one thing. By our standards, that doesn't even count. In other words, everything worked out on the first try.
pre-welded the hinge and then moved the axis a little bit in this direction so the door would stay in place but still slide out. We did the preliminary and rough setup in that general direction, carefully connected the motor there. Were absolutely no remotes or any other control devices yet, just to thoroughly check and observe precisely how it functions. Let's proceed with the very first startup. It indeed works and everything visibly moves as intended. For now, it's solely operated via simple buttons with no remote control, nothing else, just power directly from a temporary test battery. But everything is fully operational and functions perfectly. Later, when the control system is connected, the magnetic components will work too. Straps will be installed to catch it and set it into the gaps properly. That's it. As it is, the mechanism is functional and ready. All that's left is to connect it and add the cover. We'll change the cover too, because this one really doesn't fit here at all. We've received another package. These are electric struts for the trunk lid from a Toyota RAV4. We're going to install them on the Buchanka. Now we'll unpack them. Here's what it looks like. Now we'll try it out. Connect it, run it up and down, find out the upper and lower positions, and then we'll carefully try it on the car to make sure the lid opens wide enough. We also got these robust hinges from Midea for mounting it securely. Now we'll try everything on, cut, saw, and weld precisely.
So why did we decide to use these electric struts from Toyota? It's simple. This was the only used option of the right size and for a reasonable price. What's the idea here? Since we're building a Buchanka from the future, we'll try to incorporate as many electric drives and other mechanisms as possible, just like modern car manufacturers do. That's exactly what Kolya is working on.
So I should probably explain how the trunk lid opening system will actually work. Our struts are from a RAV4. Here we had to uncrimp the factory crimping to flip the ball joint the way we need it. That's why there's a temporary clamp here right now. Later we'll most likely put a couple of tack welds here and fit the factory rubber cover back on. To make all this work effectively, we'll definitely need trunk lid locks. We took trunk lid locks from a Seat Toledo. They were readily available, and which is important for us, they have a loop for the central locking system. For opening, we'll use the simplest actuators, which are sold absolutely everywhere. It's a standard robust central locking actuator system. We use these locks so that the actuator itself effectively closes the door, firmly slams it shut, and securely latches it. When the actuator isn't powered, when it's not actively working, it's always in an extended, fully open position. There's a spring inside. There's a screw pair, and it's always in an extended state, so if you just cut the power, the door will open by itself. That's why when the actuator closes the trunk lid, the lid needs to latch into the locks, and everything should open synchronously. We will send a single signal simultaneously to both actuators, and it will open the lid. In the future, most likely, the opening speed and all these parameters will be controlled by our electronics. But we'll look into that a bit later when we integrate the whole. We finished all mechanical work on the trunk and installed the shock absorbers. We've installed the locks. The lock actuator, everything is temporarily connected with makeshift wiring from a 12-volt unit to a button. In the future, all this will be integrated into the car's overall system. Right now, that's how everything is connected, because more components will be added and some things will change. But for now, it's connected in this particular way. This specific configuration makes it quite easy to thoroughly check the mechanics, so we can then move on to other important things. For the moment, it simply opens with a straightforward button. Here, it operates automatically, and you can easily raise it higher yourself. Indeed, it lifts up quite high, and when it closes, it securely closes like this and firmly latches into the lock mechanism. Later on, the door's opening speed and its opening height will be fully adjustable, but that particular functionality will be controlled by software. We're not implementing that now because this is still a very rough version, so we can continue working on the glazing and everything else that is necessary.
Well, now let's move on to the most interesting part. The idea is that we want to travel into the future in a futuristic Buchanka and control it using a joystick. Of course, there are no ready-made solutions for this either, so we bought a steering rack and a separate electric power steering unit. That's what Kolya is taking apart right now.
parts for installing the steering system on the Bukhanka have arrived. We decided to use a steering rack. The steering rack is a manual one from a Toyota RAV4. Our vehicle isn't small, so we looked for a sturdy steering rack, not from a compact car or anything like that, but a manual one without hydraulic power steering, because we're going to install an electric power steering unit. The electric power steering will be from a Renault Clio 3. The car is small, but the electric power steering is quite solid and sturdy. I'll show you a bit later how we'll connect and install it. To integrate all this into the car, we'll be using steering universal joints. This one is from the Renault Clio's electric power steering, and this universal joint is from the RAV4 steering rack. We also had some parts custom made by machinists. Here are the kinds of extensions for the steering shaft itself, for the steering rack shaft. These are needed to align the axis of the tie rod end with the axis of the control arms. To avoid unwanted wheel oscillations when the suspension is working, we'll be using these. We have standard tie rod ends from Easy. To connect them to the tie rods, these adapters were also machined. Here are these bushing adapters. For now, we've temporarily picked out these dust boots, and we've roughly made a set of mounts for attaching to the body. All of this will be fitted more precisely on the car itself.
First, we carefully test-fit the already modified steering rack, and then take precise measurements to figure out exactly where and how we can design the mounts. The next step is working on the mounts, anchor plates and other elements that will secure all the parts in place. Everything here is clear and straightforward. Thicker metal, more welding, dozens of test fits and adjustments.
We installed the rack in its proper place. We tried to position it as close as possible to the axis of the tie rod ends so that these joints would be aligned with the control arm axis. The steering rods themselves are parallel to the control arms. We use factory Isuzu tie rod ends. We had this twist piece custom made by a machinist. We were lucky that the threads on the Toyota, RAV and Isuzu rods are the same. So we managed without welding and just ordered these simple couplers. We have successfully joined together two robust universal joints, specifically sourced from a RAV4, ensuring a secure and precise connection. And here we have the Clio 3, which is now seamlessly connected to the electric power steering system. Regarding the common issues frequently encountered with these setups, it's often observed that everything tends to wear out, including the crucial bushings. However, in this instance, you have diligently replaced them, addressing a key point of failure. Overall, we are executing everything quite competently. Really, thank you. There's nothing more to say. All right, Kadrandi, let's keep filming. Here you can clearly see why we use these extensions to move the ball joint from this spot to this spot onto the axis of the lever's movement, so that when the lever operates, nothing changes. We connected the universal joints from the RAV4 steering rack and from the Clio 3. For now, this is just for testing. In the future, we'll weld and reinforce it here. As I mentioned earlier, connecting this electric power steering is absolutely straightforward. Connect positive and negative terminals, hook to battery, and connect control positive from ignition switch. That's it, connect to positive terminal. There was a click that means the power steering has started up. That's it. And now the wheels turn much more easily. It starts working, and so do the wheels. The wheels turn quite easily, actually. The steering angle of the wheels is quite acceptable. This is the steering angle we've achieved with the wheels. It's actually not small at all, which is a very good and positive thing indeed, and quite impressive, demonstrating excellent maneuverability. So why did we install the rack in this particular way? The electric power steering is on the right side. We'll explain that to you a bit later. Here is our stepper motor, which will control our steering. I've already installed the adapter bushing on it. We've prepared a couple of plates. We're going to install everything. So, in order to connect our motor and the steering shaft coming out of the electric power steering, we made this bushing. It's for the keyway. We cut off the excess and make a keyway in the bushing. Everything will be mounted with this bushing, and the motor will also come out of the bushing with everything made for the keyway.
As a result, after installing the stepper motor, we'll have the following setup. The stepper motor receives a signal from the joystick. It determines which direction and at what speed to turn the wheels. Of course, the stepper motor alone can't handle such force. That's why it's connected to the rack through an electric power steering unit.
So now we will proceed to run a comprehensive test of our carefully assembled system. For this setup, we have integrated several key components: an Arduino joystick, a dedicated stepper motor driver, and a robust 12-volt battery. The 12-volt battery specifically powers the electric power steering system, ensuring its proper function. Concurrently, a separate power supply is utilized to energize the stepper motor driver. Now, with everything connected and powered on, we will activate the system and observe how the wheels turn. Alright, there it smoothly goes all the way to the complete stop, and now it moves to the other side. Excellent. Full range. Right now, this is all put together on the fly, but later it will be a full-fledged program with an encoder tracking the number of turns, the central position of the wheels, and everything else.